Hello everyone and welcome to video 6 in my series on how to build a Redstone CPU. So in this video we changed the instruction set, we doubled the capacity, thus making the inputs for the opcodes 3 bits instead of just the original 2. We also dropped the add operation because it's not one wide, so it significantly increases the size of the ALU, and messing with carries and stuff, it just doesn't match the design that I'm going for. So it would be easy to add back in, but in this design, it's not here. So some of the instructions in here are not your typical logic gates, such as, not is a logic gate, but it's not a 2 operand logic gate. So like these first 6, they all use 2 inputs, whereas not will only use 1, and NOP, which stands for no operation, will only use 1, or it won't even use any because it does nothing. So uh, these are influenced by x86 assembly to a degree. For example, I took NOP or no operation from assembly, and that's basically used to create a buffer or uh, pad a disk descriptor or a file system descriptor. So that's what that's for, and that's mostly because I couldn't come up with another logic gate to put here. So yeah, uh, I didn't want to use another adder just because they take up space. So let's begin. I already built one. Uh, As you can see, it's not a whole lot larger than our previous version with only half the operations, and that's because the adder takes up the room of 3 operations on its own. So it's, I think, 2 blocks wider in this direction, and it's, I believe, 2 blocks longer in this direction. I don't know what to call them, but so I guess let's begin building. We need 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 spots between the purples. So come out here. We need 3 spots for the opcode. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Space. Okay. So then we will build our typical bus for the inputs right here. Now, this time we do need to go the full distance of the signal strength because, as it so happens, 8 times 2 is 16, which is the maximum length of signal strength in Minecraft. So, yeah. So we just bring this out a ways and see where it stops. Okay, so it stops here and it lines up. So I think we're good. I'll leave those there just in case we do need to use them, but I'm pretty sure we don't. I think I might have made a mistake. I think it only goes 15 blocks, but it's kind of irrelevant because since the last operation is a NOP or no operation, it doesn't even need the inputs, so it's kind of useless. So let's begin. The first gate is an AND gate as per the previous version. So I'll be using the same exact design because it's easy. Okay, now we'll do an OR gate. Same exact design. Now XOR. Okay, now the next command is NAND, N-A-N-D, which is like AND, but with a NOT gate after it. So if we were to just take off this torch, we'd have a NAND gate, which is exactly what we're going to do. So crap, how do I build these? Okay, so there's our NAND gate. Next would be a NOR, which is an OR plus a NOT gate, so we'll be just putting a torch here. Next would be the XNOR, which we could just put a torch here. Oh, reminds me I need to put that there. But that's a little bit slower, and there's a more compact XNOR. I don't remember how to build it off the top of my head, so I'm just going to copy it from the one I already built. So, 2 diagonal and a 3 diagonal. Okay, and one key thing to note about this XNOR is it cannot take repeater inputs. So we do need to go out one more block of redstone. And that's because repeater input is, I don't know how to say this, maybe stronger. Is that maybe a good description? I don't know. But it allows it to go on to blocks that it normally wouldn't be able to go on to. So that's the reason why we're not going to be, why it has to stick out one further than normal. Okay, so we've got 2 repeaters and 2 torches right beside them. I have not yet found the forum thread that I got these off of. They're all just kind of built on a world that I already have. But if someone has the link to the thread, I'll gladly put it in the description. So there's that. Next would be the NOT gate, which is fairly simple to build. As a general rule of thumb, I always build out the inputs even if I don't use them, like so. So we won't be using this top input because we only need to knot the bottom. So, yeah. So there's our NOT gate. And for our final no operation, I think the signal strength actually expires right here, but it's okay because we don't need it. But we would normally put a repeater right here. So let's go ahead and just test the signal strength one time. Okay, so never mind, it does reach all the way, which is nice to know, but kind of useless. Okay, so same as on the previous design, we need the outputs to be 5 tall, so let's just build them up. That's 1, 2, 3, 4, 5. Can't do that, so 2, 3, 4, 5. 1, 2, 3, 4, 5. One, two, three, 4, 5. 3, 4, 5. And like I said in the previous video, we try to escalate them to the level they're supposed to be at as quickly as possible. So that way we don't have to, if we need to put repeaters or something, it's a lot easier if it's already at the level it needs to be at. I don't know if that made sense, but it made sense in my head before I said it. 2, 3, 4, 5. Okay, so now we just put the redstone on these buses here. And notice how we're not building a bus from the NOP, or the no operation, just because I don't really want to. So this one and this one stick out the furthest, so we're going to make these stick out the same amount. Okay, so I guess let's begin building the binary decoder as always. So we're going to have to build out twice as far, and we do need to add this third bit because we're now using 3-bit instructions. So we are going to build out one for the NOP as well, even though we won't be using it, because if I wanted to put another instruction there, there would need to be a slot in the binary decoder. So we're going to go ahead and leave that there. Oh crap, I missed. That was bad. Okay, so let's go over here, build down 2, and then we'll just make this a rail all the way across. And go back and delete every other one. Okay, so let's go ahead and set up our decoder. So we've got all zeros, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay, so those are all placed. Let's get the repeaters all down. One more set. Okay, so now for all the blank ones, we're going to put a torch on the side. Okay. Now we'll build the alternating layer right here. And just to make it easier for later on, we'll go ahead and place these wherever there's not a torch. Another layer. Oh shit, okay. So this goes here. And wherever there's not a torch, we're going to place one. So here, 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 and here. One more layer. And just put a torch everywhere there isn't one. And delete all the ones in the middle. Crap. I don't think I messed up anything. Okay, so now we just build the rail on top. we build out one right here. One more. And we'll dig down right here. And this will be our output rail. So we'll color it orange as per the original specification in video 1. Put some redstone on it. So if we put a torch here, we're going to replace this with a repeater, because if the power comes from here, it's going to expire right here. This is the last block, so we need the repeater here. Okay, and we'll also need a repeater right here. So now the last step would be to put this redstone on top here. And then we just need to finish the blue buses right here, and we will be done with this ALU. So, as per the last video, you can stack these pretty much however you want to. It'll work pretty much no matter what. It does not have the carry-ins and stuff, so you don't have to worry about that at all. If you wanted to convert the NOP to an adder, that would work, I guess. I just didn't want to make it any bigger than it needed to be. So if we just finish up this, put torches up here, and there we go. Another ALU. So as you can see, it is a little bit larger, but it does do twice as many operations as the previous edition. So I think that's it for this video. Thank you for watching. I believe the next video, heck, let's just look what it is. So video 7, we're going to build, and I'll show you how to use RAM and registers so that you can store values without having to, put them into your input panel every time. Thank you for watching.